Kathryn Waltenburg, and I'm a PhD student in the School of Earth Sciences at UQ. My field of research is in geochronology, which measures how old rocks and minerals are in order to figure out how the Earth has changed over its 4.5 billion year history. To work out the age of a rock, I use the radioactive decay of certain isotopes. This is similar to carbon dating in archaeology, except that instead of carbon isotopes, I use isotopes of potassium and argon. I measure the buildup of argon relative to the potassium isotopes, and from there I can measure the age of a rock. You can apply this technique to a range of geological situations. For example, you can figure out when a volcano last erupted, or how old an ore deposit is, or you can analyse meteorites to learn more about the age of the solar system. Some of my research is about understanding how Australia has changed through time. This type of research has big implications for space science. I was recently working on a project to develop an instrument that a rover could use to date rocks on Mars. On Mars, there are some areas where minerals which form only in the presence of liquid water have been found. This suggests that there was once liquid water on Mars. Another of my research projects is to take these exact minerals and figure out how to date them, which has big implications for figuring out how long ago there was water on Mars. Earth science is great because it's a very practical field. You can take a rock and learn so much from the information stored inside it. I find it amazing that you can study a rock down to the atomic scale and use it to learn about entire landscapes. Being a researcher doesn't necessarily mean you're in a lab all the time. The rocks won't come to you, so a geologist can travel anywhere in the world to study geology. Geology is a great field for someone who likes the outdoors and isn't afraid of getting a bit dirty.